This video is about how to apply properties of limits, especially when you're given a graph. Now, a lot of the limit properties you'll encounter are kind of straightforward. For example, this limit property that says the limit as x approaches c of f of x plus g of x. A lot of these are intuitive because the way that you would, if you had a limit as x approaches c of two different functions added together, you can simply just split that limit up, the limit as x approaches c of f of x, and then add it to the limit as x approaches c of g of x. You would just add those numbers together. You would do the same thing if you were having to subtract f of x and g of x. Or there's another limit property says that if you have the limit as x approaches c of k times a function, the way that you could calculate that is you could find the limit as x approaches c of that function and then multiply that whole thing times whatever a constant was. So most of the limit properties are pretty straightforward. Multiplication works the same way. If you were taking the limit of a product, you could split it and find the limits individually. The same thing with division. If you were going to take the limit of a quotient, you could find the limit of the top, the limit of the bottom, and then divide those together. Some are a little more not as straightforward. So for example, and here's what this example is about. There is a limit property that for composition of functions. So you see we have a composition of function in this problem right here. So here is that limit property. The limit as x approaches c of f of g of x is equal to f of the limit as x approaches c of g of x, as long as, so that's our special qualification here, as long as f is continuous at that value, or at the place where the limit as x approaches c of g of x. So let me show you how that works. So I'm going to try the limit as x approaches -7 of f of g of x. So that means that I need to find first the limit as x approaches -7 of the inside function g of x. So I'm going to go to my picture g. When x is -7, I see that the limit is -1. So that means that I can find the limit of the composition by just finding f of -1 as long as f is continuous at -1. So let's see. Is f continuous at -1? Well, I don't know because all I see is a picture of g. So let's scroll down and find f at -1. Oh my goodness, look, at -1, f is not continuous. So then that means this limit does not exist. So we would select does not exist. Submit my answer. And we are correct. So we'll do another one of those. Let me find another one. So here's another one of those. This time we're finding the limit as x approaches 2 of f of g of x. So that means that I can find f of the limit as x approaches 2 of g of x, as long as f is continuous at that value. So as x approaches 2 on the graph of g, I'm getting the limit to be -1. So the limit of this composition will be f of -1 as long as f is continuous at x equals negative 1. So let's scroll down and let's see if that's true. Or sorry, not if that's true, is f continuous at negative 1? Look, here's the graph of f. F is continuous at negative 1, and f of negative 1 is 6. So my answer for this is 6. And then we'll type that in. There we go. Here's an example where you have to find the limit of a product. So the limit of the product property says that if you need to find the limit as x approaches c of f of x times g of x, then you can split that up and find the limit of each function at c and then multiply those results together. So here I'm trying to find the limit as x approaches 4 of f of x times g of x. So I will find, I'll just say this equals the limit as x approaches 4 of f of x times the limit as x approaches 4 of g of x. So then I'll first find the limit as x approaches 4 of f. Well, at 4, the limit as x approaches 4 ends up right here. I get 5, and then I'll multiply that by, let's look down at g. The limit as x approaches 4 at g, oh my goodness, it doesn't exist. Well, 5 times something that does not exist, overall itself does not exist. So we will select does not exist and then submit our answer. Then you'll have some where you're applying the division property. So here's that property of limits. That would be the limit as x approaches c. We can't write right now. The limit as x approaches c of a function divided by another function. I can find that by splitting it up and finding the limit as x approaches c of f divided by the limit as x approaches c of g. So in other words, find the limits separately and then divide the result. So here I'm going to find the limit as x approaches negative 1 of f, and then I'm going to divide that by the limit as x approaches negative 1 of g. So I have a picture of f. As x approaches negative 1, I get 1 for my limit for f. And then for g, scroll down, as x approaches negative 1, we get negative 1 for g. And so 1 divided by negative 1 is negative 1. We'll type in our result. There we go. Move on to another problem. When you're trying to find the limit of a function raised to a power, you can find the limit as x approaches that constant of the function and then square the result. That is another limit property that we can apply. So the limit as x approaches negative 3 of f of x is negative 5, but then we'll square it and get 25. Now this last example, there's actually a couple ways that you can figure this out. So there's one way you can do this, and we can do this numerically. So we've got the limit as x approaches 6 of f of x plus 3. But if I don't want to do that, I could find the limit as x approaches a different number of f of x. So instead of a limit of x approaching 6, I can find the limit as x approaches, and then you see this expression x minus 3. Substitute 6 in there. We'll get 6 minus 3 to get 3. So that's how I find my new limit as x approaches 3 of just f of x. My stylus went out, so this last one is going to look a little rough. Okay, so then I can just look at this and say, okay, here's f. Limit as x approaches 3 is 0, so I'll write 0 as my answer. Another way that you can think of this is by all those transformations that we learned in Algebra 2 and maybe even in pre-cal. X minus 3 shifts the entire graph to the right 3. But if I want to shift everything to the right 3 without redrawing everything, one thing I can do is move my y-axis to the left 3. And so that would be what my graph looked like if I moved everything to the right 3. So then I could say, okay, I want to approach 6. Well, this is 1, 2, 3, 4, 5, 6. This 3 is now 6. And the limit as x approaches 6 of the shifted graph is 0. And so then I'll just say this is equal to 0. I'll type in my answer. And there we go. So this is what your assignment is about. If you have any questions, you can click the Zoom link or schedule a help session. This is our last lesson in the unit. So next class, you'll be reviewing. And then the class after that, you'll be taking a test about limits. So good luck with this. Let me know if you need anything. Have a great day, guys.